Hello, good evening, Mom. Good evening, classmate. We are the Week 3 reporter, and our topic is all about capacity planning. I am SPJB Domingo, and I am the first reporter. Capacity planning. First, let us define what is capacity planning. Capacity planning is a process that identifies whether or not you have resources and skills to do the work or the supply to meet the demand. It's a planning process designed to help you determine if the organization has enough people, resource according to skill sets. It looks at the availability of those resource at the skill set team level. Then it facilitates the decision-making process to hire resources or therefore approve or cancel projects. Capacity planning is about supply and demand. Next, we have 4 types of capacity planning. First, we have long-term capacity planning. Second is a short-term capacity planning. Third is finite capacity planning. Fourth is infinite capacity planning, which will be discussed later on. For now, we will discuss about the capacity measurement. Capacity measurement. Capacity is often defined as the capability of an object, whether it is a machine, work center, or operator, to produce output for a specific time period, which can be an hour, a day, or etc. For example, type of business, restaurant. In a restaurant, they serve customers, and that is their way of knowing the capacity of both food and employees and see how many meals they can serve in the tables. That is the measurement in capacity. While unit of measurement is the meals they can provide within the day. They can provide or sell within the day. Then next we have the type of business, agriculture. For example, in harvesting of rice, the farmers can harvest 10 tons of grains per year and they work 8 hours a day. The 8 hours is the measurement of capacity, while the 10 tons of grains per year is the unit of measurement. Next, we have the priority roles. There are a number of priority roles or heuristics that can be used to select the order of jobs waiting for processing. Some well-known ones are presented in a list adapted from Volman, Berry, Weibark, and Jacobs 2005. So these are the priority roles. Random or pick any job in the queue with equal probability. This rule is often used as a benchmark for other rules. Next is first come first serve, FCFS. This rule is sometimes deemed to be fair since jobs are processed in order in which they arrived. Next is shortest processing time or SPT. The job with the shortest processing time requirement goes first. This rule tends to have reduced work in process inventory, average throughout time, and average job lateness. Next is earliest due date or EDD. The job with the earliest due date goes first. This seems to work well if the firm performance is judged by job lateness. Next is critical ratio or CR. To use this rule, one must calculate a priority index using the formula due date now over lead time remaining. This rule is widely used in practice. Next is least work remaining or LWR. An extension of SPT, this rule dictates that work be scheduled according to the processing time remaining before the job is considered to be complete. The less work remaining in a job, the earlier it is the production schedule. Next is the fewest operation remaining or FOR. This rule is another variant of SPT. It sequences jobs based on the number of successive operations remaining until the job is considered complete. The fewer operations that remain, the earlier the job is scheduled. Next is slack time or ST. This rule is variant of EDD. It utilizes variable known as a slack. Slack is computed by subtracting the sum of setup and the processing times from the time remaining until the job's due date. Jobs are run in order to the smallest amount of slack. Next is slack time per operation, ST of row. This is a variant of ST. The slack time is divided by the number of operations remaining until the job is complete, with the smallest values being scheduled first. Next is the Next, Q, NQ. NQ is based on the machine utilization. The idea is to consider queue waiting lines at each of the succeeding work centers of which jobs will go. One then selects job for processing that is going to the smallest queue, measured either in hours or jobs. Lastly, least setup or LSU. This rule maximizes utilization. The process calls for scheduling first the job that minimizes changeover time on a given machine. Next, we have the long-term capacity planning. The process of ensuring that sufficient production resources are available to meet an organization's long-range production need. It includes strategic issues involving the firm's major production facilities, interrelated with location and decision, technology, and transferability of the process of other products. Parameters that will affect the long-range capacity decision. So we have multiple products. Companies produce more than one product using the same facilities in order to increase the profit. Next is phasing in capacity. In high technology industries and industries where technology developments are very fast, the rate of obsolescence is high. Next is phasing out capacity. The outdated manufacturing facilities cause excessive plant closures and downtime. Short-term capacity planning, the strategic planning undertaken by organization for a daily, weekly, or quarterly time frame. In short-term, capacity planning concerns issue of scheduling, labor shifts, and balancing resource capacities. The goal of short-term capacity planning is to handle unexpected shifts in demands in an efficient economic manner. The time frame for short-term planning is frequently only a few days but may run as long as 6 months. Other alternatives, adding shifts, employing casual or part-time workers, the use of the floating workers, leasing workers, and the facilities subtracting. X. Firm may also increase capacity by improving the use of their resources. The most common alternatives in this category are worker cross-training and overlapping or staggering shifts. Most manufacturing firms may inventory some output ahead of demand so that any need for a capacity change is absorbed by the inventory buffer. From a technical perspective, firms may initiate a process design intended to increase productivity at workstations. Manufacturers can also shift demands to avoid capacity requirement fluctuation by backlogging, queuing demand, or lengthening the firm's lead times. Service firms accomplish the same result through scheduling appointments and reservation. Another alternative is a patrician demand by initiating a yield or revenue management system. Utilities also report success in shifting demand by the use of off-peak price. Next, we have the 4 capacity planning techniques. First, the capacity planning using overall factors or CPOF. Next is the capacity bills. Next is the resource profile. Next is the capacity requirements planning or CRP. Capacity planning using overall factors or CPOF, a C2 software system that allows commanders to maintain top sight over the battlefield, collaborate with superior peers and subordinates over live data and communication their intent. So, capacity using all-over factor is a simple manual approach to capacity planning that is based on the master production schedule and production standard that convert required units of finished goods into historical loads on each work center. Capacity bills. This technique takes bill of material used and parts produced, work center setup, and actual run times and computes capacity by multiplying the number of units required by the time needed to be produced in each. Capacity bills. A bill of capacity indicates total standard time required to produce one end product in each work center required in its manufacture. The capacity requirements at individual work centers can be estimated by multiplying the capacity bills by the MPS quantities. Resource profiles. Method is one of the techniques that can be used for a company's resource requirements planning. Includes the time-space profile of the capacity requirements for each end item. So, the resource profile or RP method is one of the techniques that can be used for a company's resource requirements planning. Example, right to capacity or RCP. The RP method takes into account the specific timing of the projected workers' individual work center. That's all. The rest will be reported to you by my group mate.
Hi, good evening. I am Elizabeth De Lapus and I am your second reporter of this group. So, Capacity Requirements Planning or the CPR, the process of determining the production capacity needed by an organization to meet changing demands for its product. So, we have a chart here, Preliminary Master Production Schedule. So, what is Master Production Schedule or the MPS? Is a main driver of the Material Requirements Plan or the MPR, along with the bills of materials. MPS can determine what components are needed from manufacturing and what components need to be purchased. The MPS is a priority plan for the manufacturing. MPR is the Material Requirements Planning and the CPR is the Capacity Requirements Planning. Does the MPS need any adjustments? If the answer is yes, it goes follows to the Preliminary Master Production Schedule. If the answer is no, it will go Final Master Production Schedule. So the importance of capacity decisions. First is the impact on the ability of the organization. Second is affect operating cost. Third, capacity major determinant of initial cost. Fourth is involve long-term commitment of resources. Fifth, affect competitiveness. And the sixth is capacity affects the ist of the management. So the next one is the aggregate planning. It is a process of developing, analyzing, and maintaining a preliminary, approximate schedule of the overall operations of an organization. Aggregate planning involves developing a general plan for employment, outputs, and all inventory levels. The goal is to develop a plan that makes efficient use of the resources of an organization. The next one is the aggregate plan. Generally contains targeted sales forecast, production levels, inventory levels, and the customer's backlogs. An attempt to balance capacity and demand in such a way that costs are minimized. So, aggregate plan is a method of developing an overall manufacturing plan that ensures uninterrupted productions at a facility. An aggregate plan specifies what materials and other resources are needed and when they should be procured to minimize the cost. Aggregate is used because planning at this level includes all resources. The first one is the total number of workers. Second one is the hours of the machine time. Third is the tons of raw materials. It does not distinguish among sizes, colors, and features, or etc. The steps taken to produce an aggregate plan, determination of the demand, and the determinant of current capacity. So, I have a table here. In the left side, options for situations in which demand needs to be increased to match the capacity. Includes pricing, promotion, back order, new demand creation. On the right side, options which can be used to increase or decrease capacity to match current demand. Includes hire or layoff, overtime, part-time or casual labor, inventory, subcontracting, cross-training, and other methods. The next one is the aggregate planning strategies. Number one is the level strategy. Stick to an aggregate plan that maintains a steady production rate and or a steady employment level. In order to satisfy changes in customer demand, the firm must raise a lower inventory levels in anticipation of increased and decreased levels of forecast demand. Next is the chase strategy. Major advantage allows inventory to be held to the lowest level possible. A chase strategy implies matching demand and capacity period by period. That's why most firms embracing the just-in-time production concept utilize a chase strategy approach to aggregate planning. Next is this table gives the advantage and disadvantages of the aggregate planning strategies. Number one is the level strategy. Advantage, able outputs rates and workforce levels. The disadvantage is greater inventory investment is required, increased overtime and idle time, Use utilizations vary over time. Next is the J strategy. Advantage, less chance for obsolete merchandise. The disadvantage is never a stable production level, workforce instability, hiring, firing costs, and always a priority. And I will give this, that's all, and I will give this to the next reporter.
Hello, I am Marjorie De Los Reyes, and I'm the third reporter of our group. The second techniques for aggregate planning is the mathematical techniques. It is a symbol used in all branches of mathematics, a formula, or to represent a constant. So for example, when we need to compute the total overtime of our workers in a week, we simply use the OT to represent the overtime in a mathematical equation. There are also other techniques for aggregate planning. First is to determine the demand for each period. Second, determine the capacity for each period. These capacities should match the demand because we will compute the subcontracting, overtime, and regular time of the workers. Third, identify company or departmental rules or policies in order to maintain reasonable, stable workforce. Fourth, determine the unit cost for units produced. This cost would include the basic production cost, back order, expenditure cost, and inventory holding. Fifth, develop alternative plans and compute the cost of each. And lastly, if satisfactory plans emerge, select the one that best satisfies objectives. Operation scheduling pertains to establishing both timing and use of resources within an organization. There are two methods of scheduling. These are forward scheduling and backward scheduling. Forward scheduling selects a plan order release date and schedules all activities from this point forward in time, while backward scheduling begins with a planned due date and moves backward in time according to the required processing times until the order will be released. So for example, we have a company that offers pool maintenance. We have a client and he wanted to schedule it in the last week of June. If we will follow the forward scheduling, we will finish the job in the last week of June as soon as possible. And if we will do the backward scheduling, we will do the job on the last week of June so that we will have more open time slot at the beginning of the week for new customers. Loading. It involves assigning jobs to work centers and various machines in the work centers. There are two types of it, infinite loading and finite loading. Infinite loading is jobs that are assigned to work centers without regard for capacity of the work centers. It simply means that infinite loading has no any limitations when developing the schedule. And finite loading is the projects, the actual start and shop items for each job at each work centers. And it also means that finite loading takes into account the actual amount of each resources will be consumed during the processing time of the products. The priority rules that is being discussed by ASB is useful in determining or selecting the jobs of various customers. A company has many and various customers. To avoid losses, we use the priority rules, which includes random, first come first serve, shortest processing time, earliest due date, critical ratio, least work remaining, fewest operation remaining, slack time per operation, next queue, and least setup. To have a proper order of customers' jobs, we will be using the Gantt chart. This is load chart and schedule chart. So load chart displays the loading and idle times for machines or departments, while schedule charts used to monitor jobs progress. So in this slide, we have an example of load chart and schedule chart. So what do we mean by this? In this example of Gantt load chart, we have a work center which is metal works, mechanical, electronics, and paintings. We also have the days of the week, which is composed of Monday, Tuesday, Wednesday, Thursday, and Friday. We can see that in this example, it has a yellow box, which means that the jobs in the work centers in this specific day is processing. And the green ones means that the work centers in that day are not available because they are having a maintenance time, repairs of the machines, or shortages of the jobs of the customers. And the white box also means that the specific work centers in that day is available. In the example of Gantt schedule chart, we can see the job ABC, and we can also see the day 1, day 2, day 3, day 4, day 5, day 6, day 7, and day 8. And we can also see the green bracket, which means it is an estimated time of starting and finishing the job. And the pink solid bar, it is an actual work progress. And the blue bar means that it is the non-production time or the maintenance time of the machines. We can also see the blue dotted line. It indicates the current date. So we will check the schedule if it is whether ahead of time, on schedule, or behind the schedule. Therefore, we can conclude that the job A is about 1/2 behind the schedule, and the job B was completed after the maintenance time. And lastly, the job C is ahead of schedule. Determination of equipment requirements, and there are 3 types of it: equipment selection, mass production, and batch production. Equipment selection is a process of identifying a set of suitable equipment which are most suitable for processing a set of products. It is important because it decides the quality, cost, and reliability to achieve customer satisfaction. Mass production established production line and equipment availability must be taken into account. And lastly, the batch production. It selects the machines by simultaneously. Determination of capacity. Capacity determinations are strategic decisions in plant planning or factory planning. Capacity decisions are important because they have a long-term impact. Capacity determines the selection of appropriate technology, type of labor, and equipments. Right capacity ensures commercial viability of the business ventures. Capacity influences the competitiveness of a firm. Measuring capacity. It is an estimate of demand for each period in the planning horizon. It is also an estimate of processing time for the workstation where the equipments will be used. This is usually obtained by one of the work measurement methods. We'll use the requirements-based formula, which is N is equal to TP over 60 DE. So what do we mean by this? So N is the number of machines required by workstation. T is the processing time per unit in minutes. P, the production rate of workstation in units of outputs. And 60 is the constant. D is the duration of period in hours. If it has 1 shift, it is equivalent into 8. And if it has 2 shifts, it is equivalent to 16. And if it has 3 shifts, it is equivalent to 24. And lastly is the E. It is the efficiency of equipment expressed as percent of running time per period. So we have an example. In this problem, we will be getting or we will solve for the number of machines that we will be using. In this problem, suppose that a fabrication section of department must supply 4,000 goods parts daily to another department for assembly. Processing time is 3.00 minutes per unit, and the equipment efficiency for 2 shifts daily is estimated at 80%. So the given formula is N is equal to TP divided by 60 DE. So N here is none, or we will be solving for the N. And the T is the processing time, which is 3 minutes per unit. And the P is the 4,000 goods parts. And D is, since it has a 2 shifts, it is equivalent to 16. And E, 80%, and we will convert it into decimal, which is 0.80. Using the formula, we will multiply the T and P, which is equivalent to 12,000. The next one, we will multiply all in the denominator, which is 60, 16, and 0.80. And the answer is 768. If we divide 12,000 divided by 768, we will be getting 15.62.5, and we will round it to the nearest place value, which is 16. So in this problem, we will be needing 16 machines in order to produce 4,000 goods parts.